The structure that we drew here is what we call the here we go. The expanded structural formula. And notice that it looks a lot like a Lewis structure, right? Because that's exactly what it is. It's just larger because this molecule is bigger. So we're going to be converting between several different types of formulas. You can take the expanded structural formula and collapse it down into what we call a condensed structural formula. In the expanded version, you can see all of the bonds and how the atoms connect to each other. In the condensed structural formula, you're going to see how the carbons connect to each other, but not the hydrogens, because we know that all of these hydrogens are connected to the same carbon, so we can kind of collapse them down into one group. So you could take this group and call that CH3. Right, I know that this group has a carbon and 3 hydrogens, and I'm just going to collapse that down into one group. That carbon is connected to the next carbon, so I could take this group and notice that I have a carbon and 2 hydrogens. So I could say, well, that's going to be a CH2 unit. 1 carbon connected to 2 hydrogens. And then that's going to connect to the next carbon. Notice this one is also a CH2 unit, and this one is a CH2 unit. So I could write both of these as CH2s. And finally, when I get to the end, it looks like this is another CH3 unit. So I would just collapse that down into CH3. And that's our condensed structural formula. So we're drawing in these bonds that are connecting the carbons, but we're not showing how the hydrogens exactly connect to the carbon. Sometimes this gets collapsed down even further, especially when you start getting into fats, like fatty acids, and you have 10 or more units of CH2. It gets really, really long and tedious to write all of those out. So this can sometimes be condensed down even further. I see that at the ends I have CH3s. In the middle, I have 3 CH2 units. So sometimes in the textbooks, you will see this written as CH2. And then in the parentheses, we're indicating that there are 3 CH2 units that connect to a CH3 at the end. So the 3 in the subscript here is indicating that there are 3 CH2 units in the previous structure. So that's an even more condensed version of a condensed structural formula. The condensed structural formula can be nice, but sometimes molecules get so big, they can have 50 atoms or more, that it gets unwieldy even with condensed structural formulas. And then we want an even better, more efficient system that enables us to draw these molecules quickly. For that, we will use line angle or bond line formulas. These are really the same thing, just different names for the same thing. They're synonyms. And in this system, every corner is a carbon. Every line is a bond. And hydrogens are not shown on the structures. So what we're going to do, let's say that we want to draw pentane in the bond line or line angle system. I want to show every carbon, and I'm going to just draw, I know that I need 5 carbons because the prefix is pent. So I'm going to just draw 5 dots in a zigzag format. Each of these dots represents a carbon. And we can even number them in case we get confused. This will be carbon 1, 2, 3, 4, and 5. Then we're going to use lines to connect all of these. Ooh, okay, that's not a straight line. And that is it. We're not showing the hydrogens. We know that they are there. So the line angle or bond line structure implies the presence of hydrogens, but it does not explicitly show them. So really you're just connecting the dots, right? This would be a line angle or bond line structure of pentane. It is really, really important to practice this because it can get very confusing to see like, where are these hydrogens? So next we will practice going from a line angle structure to an expanded structure to a condensed structure.